In the second portion of this survey, we will be asking you questions related to adaptation strategies for Site 2, which is located in West Waikiki along Alawai Boulevard. At this site, we were interested in looking at how these typical low-rise residential walk-ups may adapt with sea level rise. In this case, the spaces most vulnerable to flooding are those located at ground level / at grade. Here, we're referring to the first floor of these buildings. In the following slides, the renderings illustrate ways in which these buildings may adapt to sea level rise via various adaptation strategies over time. In this first rendering, the image depicts 2 feet of sea level rise with an additional 0.62 feet, or approximately 7 inches of water caused by a king tide event projected for 2050. In comparison to existing conditions, we can expect that with this amount of water, flooding in the street may occur regularly. You can see this to the left of the picture, where the water level meets the top of the existing curb. In this image, the less opaque portion of the street represents the current street condition if left unchanged. However, by this time frame, it would be best if certain adaptation strategies were implemented for both the buildings and the streets. Therefore, related adaptation strategies for buildings include B, elevating the entire building on some type of structural fill, as depicted by the red arrows. G, elevating exterior circulation between the street, open space, and building via ramp or stair, as highlighted in orange. H, elevating critical systems to the appropriate SLR design flood elevations. This can be done by elevating the equipment on a platform, as shown here. And 4, incorporating some form of below-grade water storage within the new fill. Other adaptation strategies include elevating the streetscape and vaulting utilities. A blow-up version of this street section will be made available after this video. In this next image, we are still looking at the same amount of sea level rise and king tide as seen in the previous slide. However, unlike the first combination of adaptation strategies, this image depicts an alternative way in which these buildings may adapt. Therefore, different from the option of elevating these buildings to appropriate SLR DFE levels, other related adaptation strategies for these buildings may include D, repurposing the ground floor use for only parking, storage, or access. Those ground floor spaces are highlighted in orange. E, relocating those ground floor uses and programs. This can be done by proposing a new floor addition to the existing structure as what is outlined in orange. The addition of a new floor will depend on the existing structure and allowable load. And I, wet flood-proof the ground floor to allow the passage of water to flow in and out of the building when flooded. For example, during the 1% annual flood chance during that year. The projected flow of water through these flood vents are those being shown with the blue arrows. Moreover, the same strategy to elevate exterior circulation via ramp or stair, as well as relocate critical systems, as discussed in the previous image, would also apply in this scenario too. Similarly, the street is also elevated with vaulted utilities. Other best practices shown in this scene include the idea of a new green roof and rainwater collection system. In this last image, a depiction of 6.7 feet of sea level rise, roughly equivalent to 6 feet and 8 inches of water, with an additional 0.85 feet or 10 inches of water caused by a king tide event projected for 2100 is shown. In comparison to existing conditions, This area of West Waikiki is projected to be entirely flooded. By the end of the century, we assumed that these types of buildings would be phased out in favor of a more dense, mixed-use development. Therefore, in this rendering, we are showing new construction by this time frame. Building adaptation strategies that should be practiced in the future include A, elevating on open foundation. The benefits of elevating buildings on an open foundation allow water to flow freely underneath the building. This flow of water is represented by the blue arrows. F, elevating interior circulation. What this means is new buildings can be designed where the location of the first floor is as high to meet appropriate SLR design flood elevations with this amount of sea level rise. The dashed line to the left represents the projected SLR DFE level that the first floor of these buildings are located at. Means of access via ramp or stair will be necessary to design for. And K, building with flood-resistant materials for spaces below the SLR DFE. Likewise, incorporating other previously discussed adaptation strategies, such as relocating critical equipment and elevating with exterior circulation, are still relevant. Overall, with this amount of water in West Waikiki, parts of the site and street may be expected to be elevated on some form of structural fill before any type of new construction can take place. Below-grade water storage tanks may be located within this new fill. Similarly, a blow-up of this street section will be provided after this video. Next, you'll be asked a series of questions related to these renderings. Please feel free to refer back to this video or the images on this survey for further reference. Mahalo.